So this is going to be like a shortcut for factoring. And this is specifically when you have two perfect square terms, right? Now, what do I mean? Well, first of all, we might want to review what a perfect square number is. What's a perfect square number? Like if we were to think about a list, talking about the number 4, that's a perfect square number. 9 is a perfect square number. 16 is a perfect square number. 25 is a perfect square number. 36, right? We know this list, right? It's really just 2 squared is 4, 3 squared, 4 squared, 5 times 5, 6 times 6, 7 times 7 is 49, 8 times 8 is 64. So those are all perfect square numbers. And not only that, obviously, x squared is a perfect square term. Or even x to the fourth. X to the fourth, you could technically consider that a perfect square term because you could take the square root of it. Right? You could take the square root of any even-powered term. So like for example, if I said what's the square root of x to the sixth, we just need to remember that the square root symbol is really the power of 1/2. So I do have x to the sixth, but instead of the square root, you could think of it as the power of 1/2. And the power of 1/2 with the power of 6, a power to a power you're supposed to multiply, that would give you x to the third. Okay? So the square root is really the power of 1/2, and you could take the square root of any even-powered term. But anyways, that's just a review for perfect square terms. Now, if you have a perfect square term, and notice it says difference of squares. So if you have the difference, what does that mean? Difference in math. Subtraction, that's right. So if you're subtracting two perfect square terms, there's a shortcut for it. Okay? So if we look at number 1, k squared is a perfect square term, and 100 is a perfect square term, right? And there's a difference between the two perfect square terms. So the shortcut is this. Take the square root of each and then plug it into your answer format. Now, what do I mean by answer format? Remember, factoring, you want the parentheses, right? Yeah? Okay. And since there is no middle term, usually we have a quadratic trinomial. Right here, since there is no middle term, we know that one sign has to be plus and the other one has to be minus. Okay? So what we're going to do in our heads is take the square root of k squared. And what is the square root of k squared? Remember, the square root means the power of 1/2. So if you were to think of k squared to the power of 1/2, a power to a power you multiply 2 times half is what? 1. So what is the square root of k squared? K. Or k to the 1, but just k, right? The square root of k squared is just k. And how about the square root of 100? If you were to think about the square root of 100, you'd get 10, right? So the trick is this, guys. If you have a perfect square term with a minus in between them, do the square root of one, do the square root of the other, and plug them into your answer format. So the square root of 100 is 10. And again, over here, the square root of k squared was k. The square root of 100 is 10. And that's it. You factored. Easy peasy lemon squeezy, right? So once again, this is called the difference of squares worksheet because we're able to apply a shortcut when you truly do have the difference of two perfect square terms. So 81, is that a perfect square term? Yes. R squared, is that a perfect square term? Yes. All you got to do is take the square root of each and plug it into your answer format, okay? So let's do our answer format, parenthesis, 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 parenthesis. Now, because this is rearranged, who cares about the arrangement? Let's just do it. What's the square root of 81? 9. What's the square root of r squared? R. And a 9 right here and an r right there. Now, because there is no middle term, you know that the middle term has to cancel out. One has to be a plus, one has to be a minus. That's it. We're done. You don't believe me? Let's distribute. Check it out. Just for practice here. I mean, this is the answer right here. But if I go 9 times 9, what do I get? 81. If I go 9 times negative r, what do I get? Negative 9r. What if I went r times 9. What do I get? Positive 9r. And what if I go to the last one? Positive r times negative r. What do I get? Negative r squared, right? And as you can see, the middle terms cancel out. And this is truly what we have in the original. 81 minus r squared. It's down here. 81 minus r squared. So this is the factored form. So this is really beautiful. It's awesome. It's way easier than what we were doing on the last section. Right? The last section we were factoring quadratic trinomials that the a value was not 1. And we had to do that long process to do by grouping and all that fun stuff. Now look at number 3. We have an a value that's not 1. That's 16. Now some of us might think, maybe I should multiply a times c. No, don't do any of that stuff. Some of us even might think I could pull out a GCF. Which is true. Do you guys want to do that? Why not? Let's pull out a GCF. Why not? Okay. What could I pull out from both terms? 4. Okay. So if we pull out a 4, what would be left? 4p squared minus 9. So why did I pull out the GCF? Because you're always supposed to try to pull out the GCF. Now, even though I do have a perfect square term here and a perfect square term there, if you're able to pull out a 4, go ahead and pull out a 4. Why? Because the inside still has perfect square terms, right? It still has perfect square terms. So, again, we have a perfect square term here and a perfect square term here. So, because there's a difference of these two perfect square terms, I'm able to write it in my factored form answer format. One of them has to be a plus, one of them has to be a minus. The only difference is that I pulled out the GCF of 4, so that 4 is simply going to come down out here in front of our final factored form answer. Now check out how easy this is. What is the square root of 4p squared? 2p. Or not 2p. Okay. Anyways, what's the square root of 9? 3. Square root of 9 is 3. And guess what? You're done. All you got to do is rewrite it. Square root of 4p squared, that's 2p. Square root of 9 is 3. You're done. The answer on the back is wrong. Okay, no, I understand. The answer on the back, I guess because they want you to just practice this shortcut, I guess they just wanted you to go with the original and say, what's the square root of that? Oh, that's 4p. And what's the square root of this? Oh, that's 6. So they just went 4p and 6, 4p and 6, and one has to be a plus, one has to be a minus. That's what they have in the back, right? Okay. Yes, this is good, this is correct, but even if you were to look at this, there's still something that you could pull out of here. A 4 and a 6, you could pull out a 2, and a 4 and a 6, you could pull out another 2, and 2 times 2 on the outside would give you the 4. Okay, so technically, the book or the worksheet, they want you to practice just taking square root of the first and square root of the last. But in reality, if you could pull out a GCF, you're supposed to pull out that GCF first. I guess what I'm trying to say is this is a correct answer, but this is a better answer. Because this one down here is completely factored. This one up here, you could still pull out 2's from the first binomial and from the second binomial, so it's not completely factored. And the instructions say factor. I guess, yeah, either one's good. Number 4. How easy is this? What's the answer? What's the square root of 4x squared? 2x. And how about the square root of 25? 5. 2x, 5. Now, since there is no middle term, one has to be a plus, one has to be a minus, right? However, notice that this 25 is a plus 25, right? And 5 times negative 5, that's not positive 25. So this doesn't work. As a matter of fact, if I were more observant and thinking about the title says difference of 2 cubes. Squares, sorry. Difference of 2 squares. Not sum, right? This is not a difference, this is an addition. So right off the bat, I can't do this situation. So this is just not factorable. You can't pull out a GCF. You can't pull out an X. You can't even do the shortcut because it's not the difference of two squares. So what do we say? We say not factorable, but on the back of this worksheet it says prime, which is the same thing. It means not factorable. And if we just went back to the instructions, it says factor if possible. If the polynomial cannot be factored, write down prime. So that's what happened on number 4. Let's take a look at number 7 here. Are those perfect square terms? Both of them? Yes. Is there a difference between both of these perfect square terms? Yes. So we could actually jump to the shortcut. Let's take the square root of this first one, right? If I take the square root of 121m squared, what do I get? 11m. If I take the square root of 144p squared, what do I get? 12p. Oh, m, not n. Sorry. I was just checking to see if you guys are paying it. Okay, I messed up, sorry. So yeah, 11m and 12p. One's going to be a plus, one's going to be a minus. 11m, 12p, we're done. So it's that simple. When you do have perfect square terms, both of them, with the minus sign between them, you could just jump to that answer format. Now if I take a look at number 8, are those perfect square terms? Not yet, right? Let's first start by trying to pull out a GCF. What's a GCF there? 4? Okay. 4 will work. 4 will work, but 8 is the GCF, the greatest. The 8 is greater than 4. So let's pull out the 8. If we pull out an 8, what will be left on the inside? 4 minus y squared. Yay or nay? Okay, now if we look at the inside of the parentheses, let's ignore the 8 for a while. If we look at the inside of the parentheses right there, isn't this the difference of a perfect square term and a perfect square term? All right, so let's just use our shortcut right there, parenthesis, 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 and let's think, what is the square root of this guy? 2. And what is the square root of y squared? Y. So you put the 2, you put the y. Now because it's difference, we know that it's going to be 1 plus right here and 1 minus right there. Now let's not forget about the 8 that's out here in the front. Bring down the 8. And there's your final factored form. Do they have this in the back? Yeah. Good. So let's jump to the second part of this worksheet. Number 16 says solve each equation by factoring. Okay. Now factoring, that means that you want to be able to get it equal. Well, let's move the 81 over, yeah? Let's move the 81 over. You want it to be equal to 0 first, because if you have it equal to 0, then you'll be able to factor, split, and solve using the zero product property. Anyway, if you subtract 81 from both sides, you will have 4y squared minus 81 equals 0. Now, what are we practicing on this worksheet? We're practicing the difference of two squares. And that's what we have here. You have a perfect square term right here. You have a perfect square term over here. So let's use our factored form answer format to factor. So what's the square root of 4y squared? 2y. How about the square root of 81? So you have a 2y and a 9, a 2y and a 9. One has to be plus, one has to be minus. And now that we have something times something equal to 0, we could split them and solve. So we're going to have 2y plus 9 equals 0 and 2y minus 9 equals 0. And of course we subtract 9 on both sides. You'll have 2y equals negative 9, and then the final step would be to divide by 2 on both sides. So we get y equals negative 9 halves. Now the other one, if you do the work, it's the same exact equation. It's just the sign change. So if you go plus 9, it's going to be the same exact answer. The only thing is going to be plus 9 over 2. So those are your two answers for that one. We'll pick this up on the next video.